Hi, my name is Noah Gift, and we're going to talk about Python functions in under an hour. Really, the idea with Python functions is it's a unit of work. It has an input, it has some work that's done, and you return back that work. It works very well with things like AWS Lambda, with command line tools, with microservices. They're all incredible ways to really take the power of a function and put it into production. So in about an hour or a little under an hour, we're going to teach you to master Python functions. Let's go ahead and get started. And we'll call this one Python functions, or just functions, even easier, like this. And again, I'll do the same structure. So hopefully this is a pattern that you can steal yourself anytime you're using Jupyter Notebook. I think it's a great way to have notes here. We'll say, how about getting started with functions? So we'll do this, getting started with functions. So what are the things that are important to know about with a function? I think the key detail to get started with is that a function is something that collects logic. And so if we look at this, we could do var equals 1. That just stores a variable. We could do something kind of similar with a Python function. You could do this. You could do simple function, like this, and in order to define a function, this is really the syntax. You say def, you name it, you put these parentheses around it, and you put this. That's the simplest possible function. And in fact, you could do it in one line of code, but it doesn't do anything, right? There's nothing inside of there. What if we want to make it a little more sophisticated? We would do the same thing. Let's just take this part, simple function 2, and then we got to put something inside. So what we could do is we could just return back 1. So essentially this is now becoming like a variable, right? So it's not that great. It does something, but it doesn't do much. And to call it, you put in the brackets again, these round brackets. So parentheses. So simple function 2, 1, doesn't really do much. So why would we use a function then? Well, a function really starts to come into play when you can actually put things into it. And so that's really the next thing. Let's put things into the function, right? And this is a great way to learn functions here. Is let's do math, right? That's one of the easier ways to learn a function. So if we do add, we can actually put things inside of this function. So we can say x and y, right? That's a pretty common variable you'd see in elementary math. And so what we can do is we can say we want to return the x plus the y, just like that. And in this case, in order to add something, we just do this. We just say 1 and 1. There we go. We got 2. And now this is where it becomes very different than the variable, because unlike the variable, it's stuck, right? It's static at whatever I assign to it. In this, it's dynamic. And so I can say add 2 and 2. Right now, it does a lot of different things. Right, so we really have a piece of logic that's reusable over and over and over again. Like to stay with food and home items here, it's a little bit like a great cup. Like I actually have a cup that I have right here, and this cup is awesome because I can put a cold drink in it and it keeps it cold. Like this is my cold brew coffee. I can keep putting stuff in there over and over again, and it's useful. It's useful, and I constantly get use of it versus a plastic cup where I drink it and throw it away, right? That's kind of like a variable. You do something with it, throw it away. A function, you're able to reuse it over and over again. So that's kind of a simple one, but what if I want to actually do a little bit more with a function? Well, one of the things that you can do with a function as well is you can put lots of different statements. In this case, this accepts something and returns it, but you could build a slightly more sophisticated function that has a little more logic inside of it. So let's go ahead and build that. Let's take some of the things we did with statements, for example. So if I say complicated function here, what we could do is we could actually maybe take we would say like my list, or let's call it my food, like this. And we could actually put inside of here, let's just put a code block above here. let's again put like a list of food together. So we'll say like foods, and we'll again put some stuff in here. We'll call this apple, eggs, and I don't know, butter. There we go. And so this foods list, we could pass it into here. And this is one of the things you have to start doing with a function, is think a little bit abstractly, where you define something that could take any variable. And we would say for food in my food, like this, we can do something with it. So we can say prints, we can say I love to wake up and eat, and we'll put in the food in the bracket. And then we could even say, so that's something we did before, but we could actually do something a little more complicated and actually put lots of statements together here. And so we could also say maybe a print statement at the beginning that says, you know, a total here would be the length of the foods, right? So this would count how many foods are inside of there, or my food, like this. And then we could say like, I am very hungry and I am ready to eat, and we could put the total here, right? Eat total foods, right? That looks pretty good. And so now we've got like a reasonably complex function here that accepts something. It has a variable that it assigns, and then we print a couple things that are inside. So what's great about this is it's now reusable. In this case, I have this, right? I have foods. So let's go ahead and use that. So we can call the function. In this case, we say complicated function like this, and we can just pass in the list that I defined up there. So let's go ahead and do that. There we go. So we can see that it says, I'm very hungry and I'm ready to eat 3 foods. I love to wake up and eat apple. I love to wake up and eat eggs. I love to wake up and eat butter. So this is kind of the essence of a function, is you're building together these little pieces of logic so that you can really do things with that logic in a more sophisticated way, and it's reusable. So in this case, look, this was just these foods, but what if I want to change it? Well, what I can do as well is I don't have to even use a pre-made variable. I could actually just put a list right in here. So what I could do is I could put in steak, and I could put, you know, ham, and I could put in bacon like this, and I could call it again. Now it says, I'm very hungry and I'm ready to eat 3 foods. I love to wake up and eat steak. I love to wake up and eat ham. I love to wake up and eat bacon. So let's go ahead and checkpoint this. And what's nice about this is that anybody that wants to play around with this, go ahead and make your own inputs to this function, and you can call it over and over and over again. And what's great about this is that it's a reusable logic, and really that's kind of the essence of why a function is so important. Is it's pieces of logic that allow you to do things with the logic. So I think this would be a good spot for a slight amount of theory. And let's get into something, Sketchpad.io, which is a drawing site here. And I'm going to build this out, and we'll make a new picture like this, okay? And then I'm gonna take my stylus here, and let's draw out a little of the theory behind a function. So we can do this. Let's make this a little bit thicker. So I'm going to change the width of this pencil here to be a little bit thicker like that. That looks pretty good. Okay. And I can just make a new one here. Okay. So a Python function, what's awesome about it is how reusable it is. Again, it's like a high performance cup versus a throwaway cup. And so the syntax here, if we just draw this out, is you do a def at first, and then you have, the function name. So we'll just put in name here. And then you have the brackets. And the brackets, why they're important, is that that's where you actually put the input. So we can do a line here and say this is the input to a function. Right here is the input. And then over here, if we go into this is where we would do the work, right? So this is where we would process something. So in this case, it could be, I don't know, like we could say x plus 1. X plus 1 is equal to, we would say actually y is equal to x plus 1. And we would just cross this out here. I guess I could just do a back here. Let's just redo that. We can say y is equal to x plus 1, right? So this is our work right here. And then you also have a return statement. And so the return statement would be, we would type in return, and then it would be whatever it is you want to return back. So really this is like the output. So you got input, you got work, and you got output. And that's really the essence of why functions are so useful. And believe it or not, you can build pretty much anything in Python if you just know that. Input, work, out. That's it. Now, let's talk a little bit about some of the things that we can build before I get a little more involved with functions here. So let's build another one of these. Let's talk about some of the things that you can do with a Python function. So we know that it's got that pattern, input, work, out. And so what can you build? Well, you can build a command line tool. And we'll build that today very simply by using that pattern. You can also build a web microservice very easily by using that same pattern. And so we can call this Python functions. And I think this needs to be evangelized about why it's so critical. Python functions is that it's the simplest way to get work done. What if you want to do distributed computing? You want to use the multiprocessing module to spawn lots of processes. We can do that as well. So you can do multiprocessing very easily by using a Python function. What else can you do with the Python function? You can also do GPU programming. Believe it or not, one of the really cool things about Python functions is that there's a library called Numba. And with Numba, especially with Colab Notebook, this is a great combo. What you can do is you can actually use the NVIDIA SDK, which is CUDA, and you can actually parallelize your code onto a high-performance GPU. So you can do really complicated operations like Mandelbrot's and, I don't know, distributed machine learning or whatever it is you want to do just by writing a Python function. What else can you do with a Python function? Well, all the rage now is serverless. And so AWS has a technology called serverless, and you do AWS Lambda. And what this does is it also allows you to build things that are in response to events. And this, again, is what's incredible about using Python functions, is that it's so amazing what you can build with cloud computing. And we'll get into a little bit of that as well when I talk about Python functions. There's even more that you can do with Python functions. And in particular, you could also write your own library with a Python function. There's more and more and more things that you can do with it. We can also talk about pandas. Pandas works very well as well with a Python function. So we'll try to see how much of those we can get into. But again, it's very trivial because a Python function is an input, the work, the output. That's it. Those three things. And once you start to understand it, it's like, this is pretty powerful. We can do a lot of things with Python functions here. So let's go back again with that knowledge. In fact, let me show you a pretty cool trick here. So I'm going to do this. I'm going to say Shift for, I'm going to screenshot this. And this is just kind of a cool trick to know about. And I'm going to make a little screenshot. I'm going to go back to my repo and I'm going to click on issues. I'm going to create a new issue. I'm going to call images like that. And then I'm going to drag this and I can go for the screenshot. There we go. And we can call this functions, just like this. And what's cool about this is now GitHub will host my image for me, like, you see, just like that. And I can actually just put this inside of our README, just like this. There we go. It's kind of cool. We can just say, there we go, Python functions. Also, by the way, you can do the same thing inside of Colab Notebook, which is also kind of a cool thing to know about. If I do a text block and I just paste this in, it works the same way because it takes Markdown. So now we've got a neat little Python functions overview inside of here. So really only a couple more things to be aware of with Python function is maybe let's talk about some of the exotic things that we can do before we start building things with functions. So let's build another block here, and let's put this down at the bottom. Just scroll this down here, and I'm going to call this, exotic items with Python functions. So one of the cool things you can do with Python functions is you can have functions that have functions inside of them. So I'm going to grab a function here that I wrote a while back and just paste this in. Let's see if this works. And I think this works. Yeah, so basically, let me just walk you through a slightly more complex function here. So notice this is the same definition. We have def attack counter, and this counts the number of attacks on a body. So this is called a docstring. This is the triple quotes. And notice that I put two variables. We've already covered variables, right? We have a lower body count and an upper body count. Now, if you want to print those out, you could print those out by uncommenting this. But look, see, I have a function that's an outer function, and then I have an inner function that's right here. And what happens is that I use a dictionary, and this has got a list of attacks. These are like Brazilian Jiu-Jitsu attacks. And what happens is I declare this. I say non-local lower body counter, non-local upper body counter. All this means is that go one layer up, just mutate this variable here. So if there was something out here, it wouldn't mutate it. Just inside of this outer function, mutate this. And so what happens is every time I call this, the inner function will keep track of the state and pass that to the outer function, so that basically this is a counter that we can actually build inside of two functions working together. And so how would I call this out? Well, I would just go through here and I would say, okay, let's build a fight here. Again, let's pretend like we're building our own video game from scratch here, and I want to build this out. There we go. Now, if I do type, what is this? If we run a type, look, it's actually a function, right? So even though I call this function, it's returning a function. So what I can do now, and that's the inner function, is I can actually start calling it. So say, okay, let's fight. Let's do a Kimura attack here. There we go, Kimura. And look, now it prints out there's one attack and there's 0 low body attacks. Okay, well, let's do the same attack again and let's see what happens. Notice what happens is it's keeping track of the state, right? It never goes away because the inner function is passing that value to the outer function that's keeping track of it. And if I want to go for a different attack, I would go through here and I would say knee bar. Now we've got 2 upper body attacks, 1 lower body attack. So what's awesome about this kind of a style is that the functions as well, if you use these a closure, which is an outer function that contains the inner function, you could build more sophisticated tools like, again, a closure here. Now, another exotic thing that you can do, and let's build another one here with Python functions, is we could also, if we want to, do something called a partial function. So let's build this out, say partial function. And let's take a look at what this code does. we say from functools import partial, and notice that this function right here has two variables that it accepts, two arguments, attack1 and attack2. And all this is very simple, right? It just says print the first attack, print the second attack. Now, if I do this, if I say partial, notice that I was able to partially call the function. Because normally, if I did this without the partial, let's go ahead and run this. Let's see what happens. If I just say, okay, multiple attacks, and I put in Kimura just by itself, it's going to blow up. Because it expects, it says, look, it's missing a positional argument attack 2, right? It just doesn't work. But if I do it with the partial, what happens is that the partial allows me to partially call it. So it's basically initializing it with a value. And then if I say attack this, and I put in a second attack, and we'll call this, I don't know, arm bar or something like this. There we go. It's able to go through and it's able to actually call it. So this is also another thing you can do with functions is you can kind of queue up like an assembly line where you build a function that you can call it over and over and over again. And eventually when it gets enough arguments, then it goes and it triggers the final operation. So functions are really, really useful in terms of what you can do with them. And there's a lot that you can get out of using these kind of exotic techniques. Now let's build one more cool technique here, and we can call this lazy evaluation. And this is an interesting concept. Is that let's talk about this real quick. Is if I have a list that let's just say like huge list, like this huge list, and let's just imagine temporarily. Let's pretend that this has got like 10,000 items in it, right? We have one, let's just pretend again it's got 1,000 or 10,000 items in it. If I printed out something that had 10,000 items, it would just be gigantic. But what you could do instead is you can use something called a yield that can only process a little bit at a time. And so if I said here and I said just process, I could say for number in huge list, let's go through here and let's yield the number. And this is called generators in Python. And the reason why this becomes handy is with cloud computing in particular. What's awesome about doing this kind of operation is that you're able to basically process infinite streams of data. So this could be network connections, it could be petabyte data. You can just sample a little bit at a time and do some kind of operation. So how would I call this? Well, if we go through here and we just say, results is equal to process like this, you can call this function. And now if I look at the type, notice that it says it's a generator. And so what that means is that you can actually do this. You can say results dot, and notice that it has basically the ability for you to process whatever is inside of that list. And so you can say typically next, I believe, is the way to do it, or you could loop over it. So you could say, for and this is just a way of throwing away a variable, for this in range 2. How about we go through here and we say print next result, like that. And let's go ahead and try that out. And notice what it does is it only processes 2 of those results. Even though I had 3 inside of here, it's only going to process 2. So that's really the concept of a generator, is it allows you to have fine-grained control over what it is that you're building inside of a function. So I'm going to show you a slightly more complex and cool thing to play around with here. So if we go through here and we build out now a little bit more sophisticated tool on top of that, let's just walk through what this does. So this particular example here says that I'm going to yield an attack each time I call this, but I use the random library in Python. So Python has a great random library that allows you to randomly select things. We can say, here's the key, here's the value, here's the key, here's the value, here's the key, here's the value. And I'm going to say while true, basically pick one of those and yield this out. So even though this is a very small amount of code, what's interesting about it is that it will infinitely yield random results from this function. So if I go through here and I run it, we can do the same thing. We can say attack is equal to lazy return attacks, just like this, and I just queue it up. And again, if I look at the type of this, what is it? It's going to be a generator. So how do I use this generator? Well, fortunately, it's pretty easy. I just say for blank in range, and I just, however many times I want to call it, let's call it 3 times. We can just say prints next attack, like that. And if I do that, there we go. We've actually got that attack, that attack, that attack. Well, what if I want to go through here and I want to run it again? What happens? There'll be different values. Look, every time I run this, it's got different values over and over again. So basically, this is another powerful technique, again, with just a little bit of code. This is like essentially 10 lines of code if you take out the comments, but it allows you to infinitely generate these random sequences. And so you could see how this could be really helpful if you're going to build some kind of a test or do something inside of your Python code that's useful, where you need to run it over and over and over and over again and always get some kind of a random result back. So it is actually pretty cool to use these more exotic examples of things. So one other thing that's pretty cool that you can do with Python functions is to know about decorators. And let's briefly talk about this. So first, let me just check this in so that people have access to this and you can play around with this yourself here. So let's go to our repo and check this out, or push this back in. There we go. Now, if we go back to the sketchpad for a second, let's talk about a decorator, which is something that is really, really common in Python, a decorator. So let's go through here and let's build up another one here. Here we go. So what is a decorator and how do I use it? So a decorator is just a function. That's the main thing to be aware of with a decorator, is that it's a Python function. And I would describe it, the best way to think about it would be that it's like a big fish that eats a little fish, right? This is the big fish, and it basically is hungry. Here we go. Here, got a little fish here, got a little fish here, and it goes to the little fish and it just grabs it and bites it, right? That's basically what a function does. Is it goes through here and it just says, hey, I want to eat this little fish, and I'm now going to control essentially what this thing is doing. And that's really in an essence what it does. And so where would you use this? Well, you see this in command line tool frameworks. That's a very common place that you see the Python function. You also see it in web, right? You see decorators in web frameworks. Another place that you see them a lot is just to change your code. Like if you want to do some kind of like instrumentation, for example, this is really common, is that people will have some kind of like a logging decorator that will do some cool stuff with their code. So these are all different things that you could do with a decorator. And so it's good to know how to use a decorator. And also sometimes you're just using a decorator, but it itself, let's demystify some of the things that you do with it, because again, it's just a Python function. So let's dive into this real quick and let's build out a decorator. So let's have a section here, and we'll call this decorators. There we go. And so how would I use a decorator? I think one of the common ways to use a decorator would be to do this. This is like the classic example of a decorator, what I do is I say from functools, which is a library that helps you build decorators in Python. And notice it says decorator factory. If I hold my mouse over it, it says decorator factory to apply to a wrapper function. And what this does is it lets you keep track of the state of the function. So if I wanted to mutate it, that you're wrapping. So look at this. I just say from time, import time, and I say timing, and I just wrap. This is the input function. So again, this is the big fish that swallows the little fish. It swallows the other function and wraps it up. And then now I can just do things with the function that I grab. So I can say, I want to keep track of the time. I want to keep track of what's passed into the function in terms of arguments and keyword arguments. This is just a regular variable, and this would be a key value pair. And then I just print basically the name of the function, because again, remember, this is the function that's passed in. Give me the name of it, give me the args, give me the keyword arguments, and return back the results of all that stuff. Okay, let's go ahead and run that. Now, how would I actually go ahead and use that? Well, remember we had this thing over here. Let's go ahead and time it out. So let's build the decorator here. So I'll just go this and I say at timing. So anytime you write a decorator, again, it's just a function. I just say at timing like this, and then I call that other code that I had earlier. I just make a new function called some attacks, and I say, okay, let's get these random attacks and let's print them out. Right, this is what I was running right up here, just this, and I just put it into a function. And if I tee this up, notice that it does the randomness, but at the very end we say here's the name of the function, which again is right there. Here are the arguments that get passed in, so nothing got passed in. And then this thing took this amount of time. So we could tweak this a little bit if we wanted to change this. Like, let's actually add a little bit of extra stuff, and we can just say, like, let's make it take an X and a Y, for example. And I guess we could say, like, if we wanted to, 1 is equal to 1, or put like a keyword argument in there as well. And then if I say inside of here something like prints, these are my variables, and I could just put these in there so we just know what they are. And we say X, and we do Y, and we do 1 here. Notice that it'll also be able to grab these as well. So if I run it again, some attacks required positional arguments. We need to call this. Let's do 1 and 2, right? Because the keyword doesn't need to be called. There we go. So notice that basically it noticed that it didn't reset this value. It only accepted the positional arguments. And so now we've got additional metadata that shows up in our instrumentation. Now, if I wanted to call that other one, I could just overwrite it, right? And I could go through here and I could say 1 is equal to 1 or something like that. And now notice that, look, it's able to accept that as well. So if you want to understand how to build your own decorators, I would say this is a great function to play around with and kind of tweak it and can kind of iterate through it, because it will give you a lot of insight into how functions are actually work. And so we covered a lot of detail here. Let's go through here and save this out. And then I'm also going to commit this back into GitHub. Okay, let's go through here. Let's scroll down and let's push this into GitHub. Okay, so we have really briefly, I think, a little bit of time for me to then highlight again all the cool stuff that you can do with Python functions here. And in particular, one of the ones I'm going to show you that's kind of a cool one is AWS. And so let's go ahead and take a look at AWS real quick. Console. And it really is the same concept as what we just covered. So let's go through here. I'm going to log in real quick. And let's try this. All right. They want to make me jump through some hoops here, which I shouldn't have a problem with. Okay, now I need to do my auth. Yeah, so I have a lot of security here on my AWS account. Okay, looks like I'm able to log in here. That's great. All right, so if you want to look at what you can do with AWS in particular, I think Lambda is definitely starts to fit very, very well with everything that we've really been talking about. And in particular, why Lambda is so awesome is that it is really the personification of what a function can actually do. And let's just play around with one real quick. So let's just go through here and say create a function, and I'm going to go through here and I'm going to say Marco Polo 1111, like that. And let's put a hyphen there, maybe that would be good. Wait, under or only, yeah, there you go, perfect. And now you can use any language to do this. So once you understand this concept of functions, like you can use all kinds of different libraries like Python, Go, Ruby, whatever. We're going to pick Python 3.9 here. And then you also, if you wanted to, which is kind of a cool concept, is you can not only do x86, but if you want to use something where you don't need necessarily libraries that support x86 and you want to do pure Python, we could pick this. So let's go ahead and do that. Let's have a little fun and let's pick this. And these are things that you could do if you want to change calling services. We're not going to do anything. We're just going to do a very basic Python function. So if we go through here and I create a Python function, everything we just covered, the same concepts apply. And this is why functions are so powerful, is that with modern cloud computing, you're really ready to go if you understand just a little bit of the concept. If you remember, again, there's input, there's work, and there's a return. This works exactly the same thing. Now, this is the trigger is your input. In this case, this is the work, and this is the return, right? So you see how it's all related? Everything is tied together. Input, work, return. So let's take a look at a very, very basic Python function here, and let's tweak it. Again, here we go. There's a function definition here. I'm going to just take out all this. I don't even need any of this, and I'm going to put in my own code here. And I'm just going to say, hey, I don't need any of your code. I'm going to process an input. Every event in a Lambda could be something different. So if I go through here and I set a trigger, notice all the things you can do. I can do web services, I can do IoT, I can do voice commands, I can do streaming systems, logs. I can actually listen to the storage. I could have images come through and get put into a bucket and then process them. All this stuff is stuff that I can do inside with a Lambda. And again, this is just the event itself signature. In my case, I'm going to build a very, very simple event and just manually call it. So I'm going to say this. I'm going to say if event, and this is a dictionary syntax, if the event name is equal to Marco, then let's go back and let's return back Polo, right? Just like the game you play when you're a kid. Otherwise, return back just no. That's it. So really, really simple, right? This is there's no code almost involved here, except for this is the entire logic. It's 3 lines of code here. We're going to say if the name appears Marco, return back Polo, otherwise no. And we could even print something to make it a little easier to understand. We could do this. We could say prints, say this is the raw event, which I think is a great idea to put this inside of your function so you can see what's happening. There we go. There's a raw event. So how do I now run this? Well, fortunately, pretty easy. I just click this button, deploy. You can see it's sub-second. Now to test it, I just say test. And by default, they give you a good template, and we can just call this one Marco, like that. And it's literally just going to take this payload here and pass it in. Now, this isn't perfect. We need to change this. So what I'm going to do is I'm just going to say name right here. is equal to Marco. And let's see what happens. Now, if I scroll down a little bit here, you'll see I can format it to make it a little bit cleaner. We create it, and now it's going to allow me to test it. What happens? It returns back Polo, right? And in fact, it even gives us this log file that says this is the raw event. And if I want to, I can even go down here earlier, and I think there's a section, oh no, it's up here, it's under monitor, that I could actually look at the logs, and I can even see that print message. If I go through here, and we go through here, and we see a print message, and we should have it right here. There we go. This is the raw event, right? So that's one of the really powerful things as well, is if when you're building one of these functions out here, is that critical to add logging, so that if you have 1,000 of these running, you can see what each one of them is actually doing, because you're putting these print statements again, because multiple people could be calling this function, and it's hard to know what's happening unless you have some kind of logging. Now, that's the positive test case. What happens with the negative test case where I call something other than Marco? Well, let's try it out. So let's actually build another one. In this case, we'll go through here and we'll build a new event, and we'll call this one Bob, and we'll say Bob. Here we go. And let's go through here and let's format it, and we'll say create. And now if I say test, there we go. Test event is Bob, response is no, right? So it did the second pathway, which is right here. So really, once you understand how to write a Python function, you can do really incredible things using tools like AWS, because again, input, work, output, and this is a great tool for you to play around with. And fortunately with AWS here, the free tier, you can call Lambda functions millions of times per month for free. So highly recommended as a great way to practice building Lambda functions.